Welcome. Yeah, so we already had a first method by which we did this here, the Laplace transform of sine t over t. And I'll leave a link to the video where I show you that first method. But here in the second method, we're going to do something clever. Recall that the Laplace transform for t times f of t is equal to the negative of the derivative of the Laplace transform for f of t. Yeah, so if f of s is the Laplace transform for f of t, what you can do to find the Laplace transform for t times f of t is take f of s, figure it out, and then take its derivative and put a negative sign in front of it. Okay, cool. So what can we do here? Well, here what we should do is take sine t over t to be f of t. That way, if sine t over t is f of t, we could look at the Laplace transform of f of t, and so the Laplace transform of sine t over t, and that's what we want. And so that let's call capital F of s. Okay. So then coming back here to the left side, we could look at what would happen if we took the Laplace transform of t times f of t, where again, f of t is sine t over t. And this is what's going to happen. Can you see what's going to happen? We're going to get Laplace transform of t times, since f of t is sine t over t, we're going to get sine t over t times t, and the t's cancel. So we just get the Laplace transform of sine t. Now, in another video, I show you how to do the Laplace transform of sine t, so I'll leave a link to that video and just state the result here. We know that the Laplace transform for sine t is going to be 1 divided by 1 plus s squared. Yeah? Okay, cool. But then this here, as it is the Laplace transform for t times f of t with f of t being sine t over t, we see that it's on the one hand this, but on the other hand equal to the negative of f prime of s, where f of s is the Laplace transform for sine t over t, which is what we're after. So we see that 1 divided by 1 plus s squared is equal to the negative of f prime of s. Yeah? Okay, cool. So that means that f prime of s is equal to negative 1 divided by 1 plus s squared. Cool. If we have f prime of s, we can certainly get to f of s by integrating, right? Okay, so that's exactly what we're going to do. We're going to take f prime of s and integrate it to get f of s. Well, when we integrate negative 1 divided by 1 plus s squared, what we get is negative tangent inverse of s, and plus c, of course. Okay, so the last thing we have to do to completely determine f of s here, the Laplace transform for sine t over t, is figure out what this constant c is. Now, by definition, the Laplace transform for sine t over t is going to be the integral from 0 to infinity of e to the minus st times sine t over t dt. Now, this here, therefore, is capital F of s, right? Okay, that looks like I said they're not equal, but I mean they're equal, right? Okay, cool. All right, so let's look at what would happen if we put f of infinity. So what is f of infinity? F of infinity would mean that this s here is infinity, and as s is by definition of the Laplace transform greater than 0, what we have here is e to the negative infinity. So this here is 0, and therefore the whole integral is going to be 0 when s is infinity. So I'm saying f of infinity is equal to 0. All right, so then we can use that information because f of s is this here, which is this here, but it's also all this, which is this here, right? So f of s is also this here. So we can plug in infinity there and set it equal to 0 because we know that f of infinity is 0. So if we do that, this is what we get, right? F of infinity is equal to 0 means that negative tan inverse of infinity plus c is equal to 0. But then we know that tan inverse of infinity is pi over 2. So what we have is 0 is equal to negative pi over 2 plus c, which means that c is equal to pi over 2, and therefore we are done. Yeah? Cool. All right. I hope you enjoyed this and keep watching. Take care.